What is up, mathletes? So today what we're going to look at is how to simplify radicals. And for today's mini lecture, we'll go ahead and we'll look at perfect squares and we'll look at perfect cubes. All right, so come along for the ride. So let's start off slow here. All right, let me talk about something. So we know the square roots of all these numbers on my left, right? So for example, if I asked you for the square root of 49, right, you already know that the square root of 49 is 7, because 7 squared gives you that that radical right there, that radicand of 49. All right, so the radicand is what we call the inside of the square root, just in case you didn't know. All right, so the question comes is, well, what happens when we get something that's not so clean? So for example, what if we have the square root of, I don't know, let's say 28. All right, so if I plug in 28, the square root of 28 in my calculator, it comes out to be a decimal. All right, so what we're gonna do when we're talking about simplifying radicals is we try to break up this number, and we want to use these numbers over here. We want to use our perfect squares. So this is how the game works, and there's so many different ways of doing it. Let me just give you one way instead of 20 confusing ways. All right, so this is what we do. We're gonna break these up, and some of you guys are really good at breaking up.
Oh no, not cool. I did not know you were there.
It's a joke, it's a joke. All right, so 28, you go, what number times another number gives me 28? But here's the catch. The very first number you use, you want it to be the largest one of these perfect squares. So I do 28 divided by 25, not happening. Divided by 16, not happening. Divided by 9, not happening. 4. So this 4 happens to be, and write this down, the largest, right? The largest perfect square. It can't just be any perfect square. It has to be the biggest, right? Go big or go home. So this is our largest perfect square. And 4 times what, right? 4 times what gives you that 28? Well, 4 times 7. So these two have to multiply to give you that 28. So write that down, right? And then the reason we do that is because we know the square root of 4. The square root of 4, that's just 2. So you don't have to go ahead and write the square root anymore. You took the square root, right? And that's why they made the song back in the day. Root it and boot it. Root it and boot it, right? And then the square root of 7, I don't know, right? So we just drop it like it's hot. Boom. So it stays the square root of 7. And this is how we simplify radicals, right? That's as far as we could go, because at 7 you cannot break it up anymore. All right, let's do another example. All right, we're just warming up here in Dr. Math Studios. Let's get the square root of 50. Same game plan. We want to break up the 50, right? We want to break up that 50. So what perfect square, not only perfect square, what's the biggest perfect square you could divide inside 50? All right, so if you heard that creepy person behind you, they said 25 times 2. All right, 25 times 2, because 25 is the biggest perfect square, right, that you could divide into 50. So what I would do, if you're just kind of getting used to this, is I'll take that 50 and I'll start dividing it by all these numbers until one of them works. If you're great at multiplication, you could just do this in your head. Right, so what's the square root of 25? Well, the square root of 25 is just 5, and the square root of 2 we do not know, so we leave it as the square root of 2. All right, so that is how we're going to simplify radicals, and the specific radicals we looked at right there are square roots, okay? If you want to see some examples of where we do variables, of what does this look like when you start to have, you know, a to the 7th power or b to the 5th power inside of there, make sure you comment below. We want to hear your suggestions so we make those type of videos. All right, so those are square roots. Now let's go ahead and let's talk about cube roots. All right, so now let's go ahead and talk about perfect cubes. So what we're gonna look at is for this example, cube roots, right? When our index, this little guy right here, this index is 3. So what this is telling us, the index, is if we're looking at perfect squares, perfect cubes, perfect fourth, and we go on and on and on and on, right? So right now this is telling us we need perfect cubes. So let's put a number in there. Let's just go with 24 for my boy Kobe. I'm really a Celtics fan. He was really my boy, but still, great player. All right. So cube root, of 24. So what we do, I'm gonna make a little mistake, and you catch me in YouTube land. What mistake was made right there? You gotta put the roots, right? So you gotta put the indices, right? So the index of each one is 3. You have to put it down. Write it down. Write that down. You'll forget it. All right. So what number times another number is going to give me 24? But it has to come from this list. That first number has to be a perfect cube. So 24, can I divide it by 27? Nope. Can I divide it by 8? Bingo. So the 8 goes in here because the 8 is the largest perfect cube. I can't stress that enough. And then we put the 3 right there. All right, what's the cube root of 8? So basically what cubed gave me 8? Well, 2. So this turns into 2. Actually, let me write that in black so I'm consistent. So that leaves me with 2. And then this cube root of 3, we don't know what it is. So we leave it the way it is. It's beautiful the way it is. So that, using the same idea, that's how we're gonna break up these cube roots. And let's do one more, just for the heck of it. And let's go ahead and do the cube root. And let's go with 250. Again, same idea, doesn't change. If this number right here in the inside, our radicand, is not a perfect cube, right, then we need to break it down. And so we break this down. We have a cube root here, a cube root there, here a cube, there a cube, everywhere cube. I have a little too much time on my hands. All right, so 250, can you divide it by 216? No. Can I divide it by 125? Bingo. So again, you're just doing this in your head or in your calculator, right? So 125 does fit inside of 250. Well, 125 times what gives me 250? 125 times 2. All right, so let's go ahead and see what cubed gives me 125. I go to my list, and my list says that 5 cubed gives me 125. So let's go ahead and write that down. That just turns into a 5. And this cube root, I have no idea, so it stays the same, and I'll leave it in red. Bam, and that's as far as I can simplify it. So this is the idea when we're simplifying radicals. Again, if you want to throw some letters, some variables in the mix here and put like x to the 12th or x to the 13th and have a whole bunch of letters, you let us know at Dr. Math Studios and we got your back. All right, folks, we'll catch you on the flip side. Peace.